We want to be able to populate both our grids with random blocks. We know that we can only have up to a certain number of variations. In this case, that's saved in these .block variations. The numbers will go from 1 to this number. For example, if this number is 6, it will go from 1 to 6. Because 0 represents an empty element. We'll create two methods. One of them will populate the main grid. Another one will populate the reserve grid. We'll be calling these methods later separately in some parts. That's why we need them separately. So match3.board.prototype. Let's call this populate grid equals function. And this will what it will do, it will iterate through all of the elements, and in each case it will generate a random number. So we need another variable which will be called variation. We're not adding new arrays, we're not adding anything, we're just modifying values. So variation will be created somehow, and then grid in row I and column J will be assigned variation. We'll have variation assigned to it. So now, how do we generate a number between 1 and whichever number has been entered as a maximum? We need these numbers to have a uniform distribution, which means that the probability of occurrence of all of these elements should be the same. The way for us to do that is the following. Firstly, get a random number in this way, which is between 0 and 1, but it's never really going to be 1. It never reaches 1. So it's between 0 and 0.9999 and forever 9. So this is multiplied by the maximum number of variations. If block variations is 7, this expression will give us a number between 0 and 6.9 and so forth. So we can bring that down to 6. It will be now between 0 and 6 by using floor, which takes you to the closest integer downwards. So we have now something between 0 and block variations minus 1. So we simply need to add 1, and now we have a number with between 1 and block variations with uniformly with the same probability of occurrence for each variation. Let's do the same for the reserve. So it's going to be almost the same, but it's called reserve grid, and also instead of being rows, this corresponds to reserve row, and the rest is exactly the same except for this part, because now we are accessing this reserve grid, and same here, we were missing the grid, this part. Okay, so let's refresh this and access our board. So we have match3. Let me increase the font size. match3.gamestate.board, and we want to do populate grid. So we have an error somewhere here. Rows is not defined because this should be it shouldn't be rows. It should be these dot rows. So congrats if you picked on that. And let's try it again. Let's try this one more time. So we can now populate the grid, and if we take a look at the actual grid, let's see what grid is looking like, and we go to them, you'll see that you have now your random numbers in there. So now you have your randomly distributed board, and also it should be for the reserve grid as well. And we can go access directly reserve grid, and we also have our numbers. Now, as you're probably thinking, this way of accessing all these arrays is being a bit time consuming. So since we'll be working on the model for a while before we jump into displaying print them in a nice way. So this allows us to go through the main grid, and this allows us to go through the reserve grid. So the reserve grid is going to be shown first because it's going to be shown on top where it belongs. So we need to define a variable that will hold a string. So this will be, we'll call it pretty string. It will be an empty string, and then for each line, every time that we finish showing a whole row, we need to skip a new line. So pretty string will be plus equal, and this gives us a new line, \n. So that gives us a new line, and then instead of this part, actually pretty string will have an empty space followed by the corresponding reserve grid value. When we finish the whole reserve grid, I want to have another extra line, and then I want to go through all of the columns again and print a dash sign so that it looks better when we put this in the console. So it looks more intuitive. It's a space and a dash sign so that it matches what we did before. And then for the actual grid, same thing. After we show each row, we want to show a new line, and then we want to be showing the corresponding grid element. So in this case, this will be just grid. And if we go to game.js, or actually we can just initiate both in here. So we no longer need to show this, we no longer need to show this, and we're going to initiate or populate grids. So this dot populate grid and this dot populate reserve grid should populate them, and then we'll do a console.log in our game state, console log. So if I refresh now, and there's something missing at the very end of this. So after we have that pretty string, we should do console log pretty string. So that's what I was missing. Let's try again. And now, as you can see, you get your visual representation. So you will be using this console log a lot because it makes it just really easy. You have to use your imagination and think that each one of these corresponds to a different color. But this is basically your board. This is the board that you'll be seeing on the screen. And this is the reserve board that every time that you clear, that you do a match 3, and that obviously destroys some of the blocks, then you get new blocks coming down. So to summarize, what we've done is populated both grids in a way that they have a random variation assigned to it, and then we've also added a console like our own sort of custom console log just to represent what's happening in the console. Instead of jumping into adding sprites and adding more issues, it's easier to work at first just on a model level using the console, and then once you get the logic right, once you get it working, then you can jump in adding the images and the animations and all that sort of thing.